Hi everyone, I am Sangeetha, Assistant Professor, EC Department, SNS College of Engineering, Coimbatore. So today I am going to share few things about the comparison of performance and power consumption of different microprocessors for different IO devices. So let us see with the basic concepts of IoT. So first, let us know what is IoT. So IoT is the Internet of Things, referred to the interconnectivity of physical devices with the internet and each other. So this allows for the collection and sharing of data. So this enables devices to interact and work together to automatic tasks and improve efficiency. So examples of IoT devices include smart home devices such as smart thermostats, lights, and security systems, and wearable devices such as fitness trackers, smart watches, and medical monitoring devices. Next one is industrial IoT, connected vehicles, that is cars and trucks that are connected to the internet and can provide data on their performance and locations. And smart agriculture. So these are some examples for IoT devices. And next we will see about the microprocessor performance and power consumptions. So the microprocessor performance and power consumption are two important factors that need to be considered when selecting a microprocessor for a specific application. So performance is generally measured by clock speed. What is the rate at which the microprocessor can execute instructions? A higher clock speed generally means better performance, as the microprocessor can execute more instruction in a given amount of time. However, the clock speed is not only the factor that determines performance, as other factors such as number of cores, cache, memory size, and instructions set also plays a very important role. So power consumption. Next let us discuss about power consumption. So power consumption is another important factor, especially for battery powered devices or applications where energy efficiency is critical. So power consumption is typically measured in watts or milliwatts, and it is influenced by factors such as microprocessor architecture, the number of cores, clock speed, and voltage. In general, higher clock speeds and more cores will lead to better performance, but also higher power consumption. On the other hand, a lower clock speed and fewer cores will lead to low performance but also low power consumption. So therefore, when selecting a microprocessor or a specific application, it is important to consider both performance and power consumption and find a balance that meets the application requirement while minimizing energy usage. Next, we will move on comparison of microprocessors for IoT devices. So there are various microprocessors available in the market for IoT devices, and their power performance, that is performance and power consumption, depends on the application requirements. So there are some microprocessors available which is currently being used in IoT applications. ARM Cortex M series. So these processors are designed for low power real time embedded applications, and Intel Quark is a low power x86 based microcontroller that is designed for microprocessor application. It is a 32-bit microprocessor that provides a balance between performance and power consumption. And next one is Texas Instruments MSP 430 is a low power 16-bit microcontroller that is mainly designed for battery power applications. And next one is Raspberry Pi. It is also a single board computer that is used for IoT application. And the last one is Arduino. It is an open source hardware platform that is used for building IoT devices. It is based on Atmel AVR microcontrollers. So in terms of power and performance and power consumption, the ARM Cortex M series processors are most energy efficient and provide a balance between performance and the power consumption. And next we will move on to microprocessor power management techniques. Microprocessor power management techniques are used to reduce power consumption of a microprocessor without significantly affecting performance. So common methods are clock gating. It is a technique in which the clock gating signal is unused to or idle ports of the microprocessor is turned off. This reduces the number of clock cycle and reduces the power management. And power gating, it is a technique in which the power supply to unused or idle parts of the microprocessor is turned off. This technique can significantly reduce power consumption when microprocessor is idle or in sleep mode. And the next one is dynamic voltage or frequency scaling, instruction set architecture, and pipeline optimization. So pipeline optimization involves optimizing the microprocessor pipeline to reduce power consumption. So this includes this includes optimizing the microprocessor pipeline to reduce power consumption. So this includes techniques such as instruction pipelining, which reduces the number of instructions needed to perform a task, and branch prediction, which reduces the number of branch mispredictions. So there are just a few examples of the power management techniques that can be used to reduce the power consumption of a microprocessor. By using a combination of these techniques, it is possible to significantly reduce the power consumption of a microprocessor without affecting the microprocessor performance. And there are some future direction and challenges. Emerging techniques and trends, that is edge computing, AI and machine learning, 5G connectivity are the future direction. And there are some challenges also. It can be solved